And then, so the Satcom radome is typically mounted on top of the plane on the fuselage, and that's a lower attachment point for lightning. So obviously the plane's going, 400, 500 miles per hour, and as a lightning strike hits it mid-flight, it's not just going to like touch it and go down. It's going to connect and then attach. So it hits like kind of like the neck of the plane. So if you're imagining a human being being in an airplane, for you listening here, as I'm trying to visualize in my head, it hits you in the neck, but you're moving so fast that then it hits you in the back, and then it hits you in the butt, and then it hits you in the foot on the way out. If that makes sense. Yeah, that was a very crude the way I'm visualizing it in my head. But so it's going to attach multiple places, right?
It does, because the lightning channel is stationary in the sky and you're moving through it. So as you move through it, it reattaches on you. And if it's attached to the top part of the airplane, which it happens to a lot, it's the top part of the fuselage, the airplane actually flies through that, and the radome actually passes through that lightning channel. It'd be like passing through a car wash. Like you're running through the car wash, right? You're going to get wet as you run through it. The strike tape, as the radome passes through that lightning channel, redirects that lightning to the airframe and away from the antennas underneath. So it's a different lighting environment. The peak current in that part of the aircraft is 100,000 amps. On the nose and the tail and the wingtips, it tends to be 200,000 amps is what the FAA requirement is. So it has a little less energy than the big strikes you see on the wingtips, but it's still damaging enough. And if 100,000 amps were to penetrate that radome, it would do a decent amount of damage to it, where it'd have to come off and get repaired, and the antenna would have a scar. A minimum would have a scar mark on it. Worst case, the electronics would be in trouble. Yeah. It's a lot of energy. Yeah, the antennas are not designed for that, right? The antennas are not designed to take a direct strike because you add so much weight and complexity to the antennas. It's a lot less expensive to make the radome to redirect the current somewhere else with strike tape than it is to try to design the antenna to handle all that current.